So in this lecture we talk about characters of G times H, where G and H are finite groups. So say we are given irreducible characters of G. So G has irreducible characters like alpha 1, alpha 2 all the way to alpha r, and H has irreducible characters beta 1, beta 2 all the way to beta s. Then we can talk about irreducible characters of G times H. So irreducible characters of G times H we will write as chi ij, where I goes from 1 to r because this I corresponds to group G, alpha 1 to alpha r, and this j corresponds to this beta 1 to beta s, where this chi ij now is a irreducible character for here, so it has to act on some element G here and H here, so you put it as the product. So obviously for G you take this alpha here, for H you take the beta, and you form the product and you find chi ij. So we'll prove this at the end of this lecture. Let us do some examples to understand it. So say we are given a character table of this group, this is cyclic group of order 2, and this is also cyclic group of order 2, same thing, and we are asked to find the character table of Z over 2Z times Z over 2Z. So cyclic group of order 2 times cyclic group of order 2. So this we are denoting as, say, by G with G1 G2 as group elements. This is H with H1 and H2 as group elements. Here we know precisely the group elements are 0 and 1. Here we also know precisely group elements are 0 and 1. So before we begin, you notice that this is isomorphic to Klein 4 group. So what we are going to write is the character table of the Klein 4 group. So the character table will look like this. So let us pick up any entry and see how it came about. So first let us look at chi 2 1 of 0 1. So chi 2 1 of 0 1. So 0 1 is here, chi 2 1 is here. So chi 2 1 of 0 1 is 1. How did it come about? So again, same formula here, I corresponding to alpha, j corresponding to beta. So 2 comes to alpha 2, 0 first element, this is G and this is H, and beta 1 of 1. So alpha 2 of 0, alpha 2 of 0 is 1, written right here, beta 1 of 1. So beta 1 of 1 is 1, comes here, 1 times 1 gives you 1. Now we want to do another thing here, say chi 2 1 of 1 0. So again same formula, alpha 2 first element 1, this 1 comes here, beta 1 0. So what is alpha 2 of 1? Alpha 2 sits right here. Alpha 2 of 1 is minus 1, that is right here. What is beta 1 of 0? Beta 1 of 0 is 1, right here. So minus 1 times 1 gives you minus 1, and that is what we wanted. Chi 2 1 of 1 0 is minus 1 right here. 1 0 is here, chi 2 1 is here. Now another example, say chi 1 2 of 0 1. So chi 1 2 of 0 1. 0 1 is here, chi 1 2 is here. So we want to show this is minus 1. Again same strategy, says 1 will correspond to alpha. So if alpha 1 2 corresponds to beta, this 0 is sitting right here, this 1 comes right here. Alpha 1 of 0 is just 1, beta 2 of 1 is minus 1, take the product, you get minus 1. So with enough practice you can actually just write it down directly. So for example, this chi 1 1 is just about alpha 1 and beta 1, but alpha 1 has all values 1, beta 1 has all values 1, so you'll just get 1. Now chi 1 2, the first element is alpha 1. Now alpha 1 is trivial character, it's always going to be 1, so everything depends upon beta 2. So you write beta 2 corresponding to 0 and 1, that is 1 minus 1, that comes here. Again here it's still alpha 1, so this doesn't matter, 1 1. Again beta 2 on 0 1 will give you 1 minus 1. So this we can again repeat. So as an exercise, now you can form a character table of Z 2Z times Z 2Z, this we have, then times Z 2Z. So you take this as our group H and this you write as group G. So you can call this as group G, you can call this as alpha 1, alpha 2, alpha 3, alpha 4, call this element as G1, this is G2, this is G3, this as G4, and then compute the character table again. So again now it will have 8 elements in it, so this 4 times 2 will give you 8. So that is pretty much it. So you can keep on doing this inductively, and that's why this is a favorite question for examiners. So now we record the character table of the cyclic group of order 2, this is Z2Z, and then cyclic group of order 3. The character table is given like this. So this we have seen before. So this is for order 2. Now we want to find the product here and its character table. So again the same story, either you can go line by line, entry by entry like this, or you can compute directly. So in the first case, this is chi11, so chi11 will always be alpha 1 corresponding to the group element and then beta 1 corresponding to the group element. So notice I have written G1 H1, G1 H2, G1 H3. So all these G1s are coming in first 3, and H1 H2 H3. This G2 comes right here. So all these 3 elements have G2 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 H1 H2 H3. So for chi11 you have alpha 1 some element, beta 1 some element, but alpha 1 is always 1, trivial character. This is always 1. So you find their product irrespective of what you do, you get 1s. So for alpha 1 2, again it is going to be alpha 1 on something, and then you are talking about beta 2 on something, but this alpha 1 is always going to be 1. So what we were left with is beta 2 acting on the second element. So this is beta 2. So beta 2 acting on H1 is 1. Then 1 times 1 will give you 1 here. Then omega, the second element we are always multiplying with is 1, so it doesn't matter. So 1 omega omega square. Again same case here. You put alpha 1 G2 here, which is going to be 1, but again everything depends upon beta 2, so 1 omega omega square. Similarly you can talk about chi of 1 3. Again first element is 1, so it doesn't matter whether you put G1 or G2, it is going to give you 1. Second element is beta 2, so beta 3, because this is 3 here, so everything depends upon beta 3, so which is 1 omega square omega, and then you're multiplying it with 1 corresponding to alpha 1, so you just get this 1 omega square omega 1 omega square omega, and you can continue this line by line. Again for chi 2 1, now you see everything depends upon alpha 2 here, because beta 1 is just the trivial character, it is always going to be 1. So depending upon alpha 2, so alpha 2 takes 1 minus 1 value. So here it is just G1 G1 G1, but alpha 2 of G1 is 1, so you get 1 1 1, because beta 1 is just 1, and then you have minus 1, so you get minus 1 minus 1 minus 1. Again you can do chi 2 2. This will depend upon alpha 2 element and then beta 2. So alpha 2 again is 1 minus 1, and so 1 is on G1, so if you have 1, then beta 2 will just come like this, 1 omega omega square, and then for G2 it is minus 1, so G2 is sitting right here, so you get minus, and you multiply with beta 2, you get this minus 1 minus omega square, and the third line. So if you find it difficult to do like this, you can practice like this, pick up an element, see so you just pick up an element. Where did this come from? This is chi 1 through chi 1 3 G1 H2, so you can say this is chi 1 3 G1 H2 is alpha 1 G1 beta 3 H2. Alpha 1 G1 is 1, beta 3 H2, beta 3 H2 is omega square. So that is how you got omega square. So again once you have this, then you can renumber this as G1 G2 G3 and so on, and this is alpha 1 alpha 2 alpha 3, and then again as a homework you can just multiply this with this and find more characters. So yeah, so this is pretty straightforward. So we will see the proof is also straightforward. So let the complete list of representation corresponding to G be this: row 1 v1, row 1 v2, all the way to row r vr, and corresponding to H you have row 1 prime w1 all the way to row s prime ws. So now we want to talk about the characters for G times H. So let us just think in terms of a single representation, row v and row prime w, and then we can talk about this I and j. And this row v comes with character alpha, and this comes with character beta. So the representation of v tensor with w, this is given as like this. So this is just the standard linear algebra. So how to form the tensor product of two vector spaces. And from here, again, the character is just character of this. We just said character of this is alpha, which is putting right here, and character of this is beta, we are putting right here. So this is just for two things, v and w. Now you can talk about, instead of v and w, you can talk about vi tensor with wj, because you have to talk about the entire list interacting with this list here. So instead of this, you can talk about chi ij gh, and then this corresponds to this and this. So basically we are just copying this to here, because instead of vw we are writing vi tensor wj. So instead of single representation, you have to talk about all of them. So this is a single character here. Now this character should make sense, that is, if you take its inner product, you should be able to tell whether it is reducible, irreducible, orthogonal, and so on. And that should completely depend upon characters alpha and beta. So to show that, we have to prove that this is equal to a product of these two, so that if it is anything is 0 here and 1 here, you get 0. You get 1 here and 0 here, you get 0. It is irreducible only if you have irreducibility here, so 1 here and 1 here. So that is the Kronecker product here. So this should depend upon product of characters alpha I and beta, just because after all, this g times h depends completely on this, so irreducibility should be preserved. So this just comes by following the definition. So this is what we have to prove, this is equal to this, and that will make sure that what we are writing here as irreducible characters makes sense, because it has to be a product like this. So just follow the definition. You write it like this, but this is equal to alpha I beta j from here, and now you just collect the alphas together. So you have alpha I alpha k comes right here, and you have beta j beta l, you come right here, and this you write as like this, and that is what, this is just the definition of this part, inner product. This is just by definition this, and that is the end of the story. So now further to see that you have all the characters, so dimension of this tensor space is given as the product of dimensions like this, but you know this vi corresponds to g, so this dimension square should give you order of set g. This is a finite group. Dimension of wj square, all these dimensions added together, w1 square plus dimension of w2 square, all the way to dimension of ws square. Let me write this down, and this we already know would give us the order of the group along which it is associated with. Yeah, so this is h, and that gives you g times h. That is it. So therefore you have all the characters. So so to find characters of g times h is pretty straightforward.